Welcome to Step 6. In Step 6, we're graduating from Smarties. We're going to use a new type of treat that's quite popular in Australia called a Malteser. Now we can buy the Malteser in two different packaging types. If I was given 3 of these small packets, I might decide to model it using the algebra 3x, where x is the number of Maltesers in one of the small packets. On the other hand, if you gave me 2 large boxes, I might also decide to use x, and I would call this 2x. This time, of course, x is a bigger number because there are more Maltesers in one of my x containers. The problem comes about when you give me both types of containers. Can you see that using the same pronumeral for both different packaging types is not going to work? So if you gave me 2 of these, I'm going to call that 2x. Now if you give me a larger box, I'm not going to call it x anymore, I'm going to call it y. Let's say my friend gives me another pack of small ones. I'm going to call that x. And I'm really lucky, I get an extra large box, which I'm going to call y. So adding all these together, I have 2x plus y plus x plus y. How am I going to simplify that expression? I think you can see that the best answer is to look at the x containers together and say I have 3 of them, and I have 2 of the y containers. So that's my answer, 3x plus 2y. Let's look at a classic error made by beginners. Here is an expression in x and y, and this is the answer that we will typically see. Can you see how they got that answer? Yes, they added up all the numbers, the 2 plus 3 plus the invisible 1 plus the 5 got 11. And then they weren't sure about the x and the y, so they just mixed it all together. The correct approach, of course, is to look at each piece individually. Notice that there are x's. So 2x's and x is 3x, and 3y and 5y is 8y. Let's see if you can do this one correctly. So 7a and 2a are 9a, and then b and 3b makes 4b. So here we have our first piece of simplifying an algebraic expression with x and y in it. This is a good time to use substitution to see if it really makes sense. Let's imagine there are 10 Maltesers in the small packets and 30 in the large packets. Looking at the left-hand side, 2x plus y plus x plus y, let's put numbers in and see what that gives. 2 lots of 10 plus 30 plus 10 plus 30. Adding that up, we get 90. How about the other side, 3x plus 2y? It should come to the same answer. 3 times 10 plus 2 times 30. And good news, it's 90. Substitution is a good way to see if your expression simplification is working. It's not going to prove it for you, but it will definitely find problems. All right, it's time now to do some exercises. Choose the column that you'd like to do, pop the video on pause, and in your exercise book, have a go at them. I'll be back soon. And here are the answers. It's time now to learn some more words for our algebra dictionary. In this expression, there are 4 components. Technically, we call these components terms. So there are 4 terms, 2x, y, 5x, and 3y. But we notice that 2 of these terms are like each other. the 2x and the 5x both have an x. And another two, y and 3y, also are like each other. They have a y in them. And this is the word we want to get to. The word is like terms. We say that 2x and 5x are like terms, and that y and 3y are like terms. So let's add that one to our algebra dictionary, like terms. Now, terms, that's the individual components of the expression, with the same pronumerals. The only difference between them is their leading number. So if you look at 2x and 5x, the only difference is the 2 and the 5. All right, one last thing to look at. Some students will get worried, is there a difference between 7x plus y or y plus 7x? The simple answer is they are both correct. It does not matter the order in which we add the terms. We'll get the same result. Here are a group of expressions which are all actually the same. Usually people like to write the expression as I've written it in the first line, 4x plus 2y plus 3. The terms are in alphabetical order and the 3 is at the end. This is a style thing. Does the order matter? No. There is, however, a preferred style. In most cases, we do like to arrange the terms in alphabetical order and put the term last. If you mix up the order, it's okay. It does look better, though, if you order them, and it makes it easier to compare work by different people, or in fact your own work, if you keep it in order. So that's a style thing. It's not a hard and fast rule. It's a style thing. So that's level 6. Like terms, the second time we've done like terms, this time with x and y. You might remember in the last step we did terms with x and just a number. And that's the word that we've learned, like terms.